Team, I made it. One last video to do. I'm losing my voice, but this is for you guys. Now let's talk about lenses. So in lenses, we have two specific lenses we talked about. It's the convex and the concave lenses. Now, we have a different word for the convex is actually converging lenses, and for the concave it is actually divergent lenses, as you can see in here. Okay, now the converging lenses are shaped so that light, all the light rays that enter it in parallel, as it is right here in a parallel, it's to the optical axis intersect at a single point opposite to the lens and the optical axis. So what it's talking about is that single point, that focal point right here. All right, and this focal point, believe it or not, is the same as equal to the radius of the curvature over 2. Notice this is also curved, therefore we have a shape that is very similar to the other ones as well, to the mirrors as well. All right, and the same thing goes for the divergent. Divergents are shaped so that all the rays that enter it actually diverge. Notice that it enters at parallel first, and then it starts diverging all around once it enters. But there are virtual rays that go back into the focal point right here. So that's the only thing I'll explain, because the equations are very similar. Now, the ray tracing is a little bit different. So in this one, the ray tracing will help us do the actual diagrams to find the image. Let's start off with understanding ray 1. So ray 1 says that, and let's do it first and this is a converging lens. Notice too that we don't actually have it like that in physics. We actually have like an arrow pointing upwards and an arrow pointing downwards to identify it as a converging lens. Okay? And I think you can possibly read the instructions. A ray entering a converging lens parallel to the optical axis passes through the focal point on the other side of the lens. So this is for a converging lens. So there are two different regulations or rules for the converging and diverging lens. I know it's a little bit complicated, I get it, but please practice this. Okay? So first one is the ray enters, it is parallel to the optical axis like it is shown in ray 1. And then it goes all the way to the focal point on the other side. Boom. Okay, that's done. Then a ray passes through the center of either converging or diverging lens. Thank God. That rule does not change, right? So it goes through the center and it hits right here. Already we can identify the image. So the next ray goes from the focal point on the near side of the object. And notice that's the difference. It is the focal point on the near side of the object, and then hits the mirror, and then finally parallel to the optical axis, and it hits the image, and we have that image. So the first one is, remember this, the first one, it goes parallel, and it hits the image opposite of where it's located. Okay, for our converging, the furthest focal point for our converging lens. Okay, the furthest focal point for our converging lens. Then for the third one, it's hitting the nearest focal point for our converging lens. Okay, now for an actual diverging lens. So the diverging lens is it's just a little bit different, because in this one it's doing the parallel, but the focal point is nearest to the object. And then for the third one, the focal point is farthest away from the object. So that is the main difference between the converging lens and the divergent lens. So the first ray for the converging lens always hits the farthest focal point, whereas the first ray for the divergent lens always hits the first focal point. But they all have to go parallel first towards the mirror and then either bounce back or go through the ray. So, all right, enough for this. Let's just do the examples, because I know, like, okay, you're talking too much. Let's do the examples. Okay. So let's first start by drawing out, like, the rays. So let's put it into perspective. Let's do ray 1, parallel to focal. All right. Ray 2, center of lens. Perfect. That's the easiest one. And then ray 3, focal to parallel. All right, so first identify. It is a divergent lens. Okay, so circle that. It is a divergent lens. Fantastic. So now we know all the divergent lens give me. So, like, remember what I said. So for a divergent lens, it is the focal point always comes first for the ray 1, and for the third one it goes for the farthest one. All right, so the first thing is going straight to the mirror, parallel to focus. So it hits the mirror, but then bounces off, and it starts going straight into the focal point. Meanwhile, the real ray bounces off and diverges. So this is a virtual ray right here. Okay, that's the first one. Now, for the second one, it is straight to the center, right? So we go straight to the center. Okay, and that is straight to the center. And we already see that the image is about to be formed right here, but we're not done. It's perfect. But the third one, as I said, for a divergent one, now it's for the furthest. So now it's from focal to parallel. So I go straight. Okay, so that's where it's gonna hit, but I don't really care for that. It's just helping me adjust of where it's actually gonna hit in the mirror, right? That's what it's helping me for. It hits the mirror, and right after it hits the mirror, it bounces. The real image, the real ray goes parallel, but the virtual image goes parallel the other way. And voila, we have our image right here. So it is virtual. It is virtual because we have two rays that are virtual. And not only that, remember what the instructions say. A ray passing through either converging lens is not deviated. This ray, green ray right here, is bouncing off a virtual ray as well. So it is going, like, what's going here is a real ray in a virtual ray as well. Okay? Because it is bouncing off. All right. Bouncing off equally. All right, now let's continue. It is not inverted. And it is smaller. Done. All right, so we're done with the first one. Let's do the second one. So the second one, it seems like it is a an actual converging lens, because again we are having our mirrors facing this way. Nice, so it is a converging lens, so we circle it. It's beautiful. Alright, so it is a converging lens. And let's start off with our ray. So our ray goes straight, and then, like I mentioned before, it goes straight from the furthest focal point. We go parallel, but then straight to the farthest focal point. Then it goes straight down the lens. All right, and then our final one goes from the object to the nearest focal point. It hits the mirror, and then that was terrible. That was a terrible line. Sorry. There we go. And it hits it right there. So the image is right here, and it is real, but it is inverted, and it seems a lot larger than the object. Okay, so again, I'm going to leave you to this one, and we're going to, honestly, because it's for this problem too, so I'm going to do it anyway. All right, so let's do this problem. Remembering, let me just highlight this. Like once you bounce off once it hits the rays, there is virtual rays that still come out of the bouncing. Okay, those are reflected rays. And right here. And finally, yep, and right here. Okay, so those are still reflected rays, but the good thing about the converging lens, once it does enter over here with actual real rays. But you'll see in this problem, it's a little bit different, but we'll do it together. Okay, so first of all, it's asking us to draw a three-ray diagram on the template below. Okay, so let's do this together. Let's use the first ray. The first ray goes from, and it is a converging lens, I believe. It is a converging lens, okay? Because it does say the. Listen, guys, I'm tired, so don't judge me. All right, it is a converging lens, so it hits here, and then it goes straight to the focal point. Remembering that there is virtual light that bounces off. Let me redo this. Okay. Bounces off. And then it says, hey, it goes from the center. And again, light bounces off. So we're already having an image right here. So it might be a little bit inaccurate because kind of like my lines are just sucking. But our last one is from the focal to the parallel. It's from this time around, it's from the nearest focal point. But the nearest focal point is all the way down here. Okay, so that sucks. But what it means is that I have to do this, and this is the tricky part. So it's going from the focal point. Since the focal point is all the way over there, the best thing that I can do is align myself so that, I'm pretty sure I grabbed there we go. Align myself so that I'm actually grabbing the actual focal point and the direction. It doesn't have to be perfect in the exam, don't worry. If there is an exam, but if it is an exam. But okay, so now what I do is erase this last part right here. Okay, and I create a virtual image from the bouncing, which is completely parallel to the actual image. Now it is kind of off. Granted, it is terribly off. I'm pretty sure it is this part right here, which is the first ray that messed up. There we go. So this is actually where the image is at. So we found the image. Okay. And it is a virtual image because all the virtual lines. It is also hot, like it's bigger than the object, and it's not inverted. Okay. And the last part is the simplest part. Calculate the location of the height of the image. So we just use the equation. 1 over distance of the object, 1 over distance of the image, 1 over the focal point. We have the distance of the object. We have the distance of the focal point, see, the focal length. And we also have the distance of the object, and we find the distance of the image, which is negative 7 centimeters. And then finally, the magnification. Magnification, well, we don't have the magnification, but we do have the height. And we're looking for the height, we do have the height of the object, sorry. And we're looking for the height of the image. And also, since the magnification allows us to equal the height of the image, the ratio of the height of the image and the object with the ratio of the distance of the image and the object, we can find the height of the image, because we have the distance of the image, the distance of the object, the height of the object. The height of the object, it is 4.0 centimeters. And sorry. All right, this concludes all my videos. I hope that you use them, and I hope that it serves your benefit. All right, I appreciate you guys. Take care and have a good night.